radius of convergence and interval of convergence. So before starting the radius of convergence and interval of convergence, let us discuss what is geometric series. We know that A plus AR plus AR square plus AR cube plus AR raised to 4, this series is converges to, so this is summation n equal to 0 to infinity a r raised to n, and this converges to a upon 1 minus r only when the absolute value of r is less than 1, otherwise it is divergent. I am rewriting the series with a equal to 1 and r equal to x. So this series is this 1 plus x square plus x cube plus x raised to 4 equal to 1 upon 1 minus x when absolute value of x less than 1. Now see, the left hand side is this summation x raised to n is 0 to infinity, and the right hand side is this 1 upon 1 minus x. When absolute value of x less than 1, then this equality is true. Okay, now we have discussed this thing. The Maclaurin series expansion of 1 upon 1 minus x is this. So this is the Maclaurin series. Now the question arises, if I have given the series summation n equal to 0 to infinity x raised to n, then can I say that the series has value 1 upon 1 minus x when absolute value of x less than 1, and when absolute value of x greater than 1, then the series summation x raised to n equal to 0 to infinity is divergent. So in radius of convergence and interval of convergence, we find the domain, that is all possible values of x for which the series is convergent or divergent. So let us define what is the radius of convergence and interval of convergence. Let summation n equal to 0 to infinity Cn into x minus x raised to x minus x 0 raised to n be a power series. Be a power series if there is a number r, there is a number r such that summation n equal to 0 to infinity Cn into x minus x 0 raised to n is convergent for absolute value of x minus x 0 less than r, then r is called the radius of convergence. The radius of convergence. And x0 minus r, x0 plus r is called the interval of convergence. The interval of convergence. So if I plot the real line, then on this line, say this is x0 and this is x0 plus r, this is x0 minus r. Then in this interval the series is convergent, otherwise in this portion the series is divergent. In this portion the series is divergent. That is our analysis. Here only 2 points remain, that is x0 minus r, this point, and x0 plus r, this point. So we also check the nature of the series, whether it is convergent or divergent at these two end points. So suppose the series is convergent either at any one end or at both the end points, right? So here we shall also note that the interval of convergence can be closed interval x0 minus r and open at x0 plus r, open at x0 minus r, close at x0 plus r, or the closed interval x0 minus r to x0 plus r. These are the also possible interval of convergence. Now the thing is, how do we find the value of r, right? So to find r, generally what we do to find r, we have given this series summation Cn x minus x0 raised to n equal to 0 to infinity. Let us compare this with summation an from n equal to 0 to infinity. So what is an? An is Cn into x minus x0 raised to n. So you can write an plus 1 also, n plus 1th term, that is Cn plus 1 x minus x0 raised to n plus 1. So to find r, we may apply the ratio test, limit n tends to infinity, absolute value of an plus 1 upon an, or you may apply root test also, absolute value of an raised to 1 upon n, whichever is convenient. Right, again I repeat, from geometric series we come to this point, summation n equal to 0 to infinity x raised to n equal to 1 upon 1 minus x, when absolute value of x less than 1 and when absolute value of x greater than 1, then summation x raised to n is divergent series. We have already seen that 1 upon 1 minus x has the Maclaurin series, summation n equal to 0 to infinity x raised to n. Now suppose we have given the series, then the question arises, can we find all possible values of x for which the series is convergent? That is the radius of convergence and interval of convergence. And here we defined how do we find the radius and interval. So let us start with the example. Exercise shall clear idea. Find the radius and interval of the convergence, for the following power series. the following power series. The first exercise is this: summation n equal to 0 to infinity x raised to n. The second example, let me write minus 1 raised to n into x raised to n, because summation x raised to n we have already seen. N equal to 0 to infinity minus 1 raised to n into x raised to n. The second example is summation n equal to 0 to infinity x minus 2 raised to n upon 10 raised to n. Third exercise is summation n equal to 0 to infinity 3x minus 2 raised to n upon n. Exercise number 4 is summation n equal to 0 to infinity minus 1 raised to n x raised to n upon n factorial. And exercise number 5 is summation n equal to 0 to infinity n factorial into x plus 2 raised to n. So let us start with the exercise number 1. We have given this series summation n equal to 0 to infinity an is equal to summation n equal to 0 to infinity minus 1 raised to n into x raised to n. Then what is an? An equal to this minus 1 raised to n into x raised to n. Right. As we discussed, we can apply any test. Now, root test or ratio test. Limit n tends to infinity, absolute value of an raised to 1 upon n. So what is this? This becomes limit n tends to infinity, absolute value of minus 1 raised to n into x raised to n whole raised to 1 upon n, and this becomes absolute value of x. Right. If you want to apply the ratio test, then what happen? An is this. Then what is an plus 1? Minus 1 raised to n plus 1 into x raised to n plus 1. Right. So r equal to limit n tends to infinity, absolute value of n plus 1 upon an. This becomes limit n tends to infinity, absolute value of minus 1 raised to n plus 1 x raised to n plus 1 upon minus 1 raised to n x raised to n. Right. So here we can cancel out x raised to n and x raised to n, minus 1 raised to n and minus 1 raised to n. Right. And the remaining quantity is absolute value of minus 1 into x, that is absolute value of x. So whatever test you apply, we have the value of r is this, absolute value of x. Now root test says if absolute value of x is less than 1, then the series is convergent. And absolute value of x greater than 1, then series is divergent. This is because of root test that we know. Right. So here actually we have the radius and interval. So let us draw the real line. So absolute value of x less than 1. So this is 0, this is 1, and this is minus 1. So this is the portion where the absolute value of x is less than 1. right? So here the series is convergent. This is the value of x in this portion where the series is divergent. So here the series is divergent, here also the series is divergent, right? Now only 2 points remain, that is 1 and -1. So how do we work with 1 and -1? Separately we substitute the value of x, 1 and -1. So let us assume that when x is 1, so in the another case when x is equal to 1, what is summation n equal to 0 to infinity, this is summation 0 to infinity minus 1 raised to n into x raised to n, but x is 1, so this is equal to summation n equal to 0 to infinity minus 1 raised to n, right? Now to check whether this series is convergent or divergent, what we do? Minus 1 raised to n into bn. Let us compare with bn, right? Therefore bn is equal to 1. This is true for all n, and limit n tends to infinity bn is equal to limit n tends to infinity bn is 1. So this is 1 which is not equal to 0. Therefore by Leibniz test summation n equal to 0 to infinity is divergent, right? What is Leibniz test? The Leibniz test is this: we have given the series summation minus 1 raised to n plus 1 into un. Then the first condition is un must be non-negative. The second one is un must be in decreasing order. The third one is limit n tends to infinity un should be equal to 0. If these three conditions hold, then we can say that summation minus 1 raised to n plus 1 un is convergent. This is the Leibniz test. So by Leibniz test, this is divergent. So what is the analysis we have? At point x equal to 1, the series is divergent. Now let us check what happen at x equal to -1. If x equal to -1, then what is summation an? This is equal to summation minus 1 raised to n into an, x raised to n. X raised to n is again minus 1 raised to n. So minus 1 raised to n into minus 1 raised to n is 1. So summation n equal to 0 to infinity 1. This is the series. So this is 1 plus 1 plus 1 plus 1. You know that infinitely many times the sum of 1 is always infinity. So this is divergent. But how do we mention mathematically n equal to 0 to infinity bn, right? Therefore bn equal to 1. So what is the limit n tends to infinity bn? This is limit n tends to infinity 1 is 1, which is not equal to 0, right? And we know that for summation an, if limit n tends to infinity an is not equal to 0, then the series is divergent. Summation an is divergent. This is the 0 test, right? Therefore summation an equal to 0 to infinity is divergent. So here we covered all the points. Let us see this real line. All the points we covered. In this open interval it is convergent, outside of the interval it is divergent, and at the end points 1 and -1 it is also divergent. So for which values of x the series is convergent, therefore the given series n equal to 0 to infinity -1 raised to n into x raised to n is convergent for x belongs to open interval -1 to 1, otherwise it is divergent, right? And therefore the interval of convergence is -1 to 1. This interval is having length 2 unit, right? See, in the real line, this is the 1 unit distance, this is another 1 unit distance, so the total distance is 2 unit. So the diameter or the length of this interval is 2 and radius is half of the diameter, so half of 2 is 1. So let us write, and the radius of convergence is 1, that is the right hand point, minus the left hand point, divided by 2. So this is 2 upon 2 is equal to 1. This is the end of exercise. Let us go for the next example. Example number 2. Summation n equal to 0 to infinity. Example number 2 is this: x minus 2 raised to n upon 10 raised to n. X minus 2 raised to n upon 10 raised to n. I am leaving this example on you. You try on this exercise, right, with the root test. I am giving you the hint. The value of r is this absolute value of x minus 2 upon 10. But the next example is similar kind of this. So if you stuck anywhere in the second example, you can use or you can find the hint from the example number 3. 3x minus 2 raised to n upon n. An is equal to 3x minus 2 raised to n upon n, and an plus 1 is 3x minus 2 raised to n plus 1 upon n plus 1. Right. Therefore, or if you want, you can apply root test also. You can apply the root test also. Now, what is r? Limit n tends to infinity, absolute value of an plus 1 upon an. So this is equal to limit n tends to infinity, absolute value of an plus 1 is 3x minus 2 raised to n plus 1 upon n plus 1. Divide by an is the multiply by n upon 3x minus 2 raised to n. Right. So this is equal to, see, 3x minus 2 raised to n is cancelled out. So this is absolute value of 3x minus 2 into limit n tends to infinity absolute value of n upon n plus 1. This limit is 1, that you can verify. So this is equal to absolute value of 3x minus 2. If some of you want the root test, then what is our limit n tends to infinity absolute value of n raised to 1 upon n. So this is limit n tends to infinity absolute value of 3x minus 2 raised to n upon n whole raised to 1 upon n. So that is nothing but absolute value of 3x minus 2 into limit n tends to infinity 1 upon n raised to 1 upon n. And you know that n raised to 1 upon n, as n tends to infinity, this is 1. So this is absolute value of 3x minus 2. Right. Now the same analysis we have when r is less than 1. That is, if absolute value of 3x minus 2 is less than 1, the series 3x minus 2 raised to n upon n from 1 to infinity is convergent. Yes, let me mention here n is equal to 1, not n is equal to 0. Otherwise it is divergent, and if absolute value of 3x minus 2 is greater than 1, then the series is divergent. Then it is divergent. Now let us go to the real line. Okay, 3x minus 2 is less than 1. Absolute value of 3x minus 2 is less than 1. So can you tell me what is happening here? Minus 1 is less than 3x minus 2 is less than 1. This is the thing actually. So let us add 2 both sides. So minus 1 plus 2 is less than 3x is less than 1 plus 2. This is nothing but minus 1 less than 3x less than 3. And if we divide both sides by 3, then minus 1 upon 3 less than x less than 3 upon 3 is 1. We are dividing by these 3. So this is the interval. Minus 1 upon 3 less than x less than 1. So say here we have minus 1 upon 3, this is 0 and this is 1. So this is the interval where the series is convergent. Otherwise means these are the points, the values of x on which the series is divergent. Only two endpoint remains when x is equal to 1 and when x is equal to minus 1 upon 3. So first let us choose what happen when x is equal to 1. If x equal to 1, then summation an n equal to 1 to infinity is this summation n equal to 1 to infinity 3x minus 2. So that is 3 into 1 minus 2 raised to n divided by n. 3 minus 2 is 1, 1 raised to n. So this is 1 raised to n upon n, which is nothing but summation n equal to 1 to infinity 1 upon n, and which is divergent. Summation 1 upon n is divergent, that you know, this is very well known series. Okay, so what happened when x equal to 1, the series is divergent. Now let us see what happened when x is equal to minus 1 upon 3. So when x is equal to minus 1 upon 3, summation n equal to 1 to infinity a n is equal to this 3 into minus 1 upon 3 minus 2 raised to, no, I think that I made the mistake somewhere here. Yes, what is the mistake? Minus 1 plus 2 is 1. Right, so this is 1. Therefore, this is 1 upon 3 less than x less than 1. So this is not 0. This is plus 1 upon 3. X is equal to plus 1 upon 3. So plus 1 upon 3 raised to n upon n. Right, so this is equal to summation n equal to 1 to infinity minus 1 raised to n upon n. Can you tell me the series is convergent or divergent? The series is convergent. The series is convergent. Why? Because by Leibniz test, 1 upon n summation n equal to 0 to infinity minus 1 raised to n upon n is convergent. Right, 1 upon n are positive, they are decreasing. Right, so that is 1 upon n is greater than 1 upon n plus 1, and limit n tends to infinity, 1 upon n equal to 0. So these are the three conditions which should be true for the convergence, and they are true, and therefore it is convergent. Right, so what happened at this end point? At this end point the series is convergent. So what is the interval of the convergence? 1 upon 3 to 1, that is open, and at this end point it is closed, right? Because at that end point it is convergent. So right, therefore the series is convergent for x belongs to closed interval 1 upon 3 to 1. Right, at right end point it is open, whether at left end point it is closed. Therefore the radius of convergence, is, what is the radius? That is the half length of this interval. So that is 1 minus 1 upon 3 divided by 2. So this is 3 minus 1, that is 2 upon 3 divided by 2 is 2 upon 6. This is the radius, and this is the interval of convergence. I hope the idea is clear, that how do we work for the interval of convergence and radius of convergence. Now see, for the next two examples, that is example number 4 and example number 5, I am discussing only the outlines of the example. Minus 1 raised to n into x raised to n upon n factorial, and this is the example n equal to 0 to infinity n factorial into x plus 2 raised to n. I am discussing only the outlines. So here an equal to minus 1 raised to n x raised to n upon n factorial. So an plus 1 is minus 1 raised to n x raised to n plus 1 upon n plus 1 factorial. Whether here an is equal to n factorial into x plus 2 raised to n and an plus 1 is equal to n plus 1 factorial into x plus 2 raised to n plus 1. Right. Now see what is happening in both these exercises. So here r is this limit n tends to infinity of absolute value of an plus 1 minus 1 raised to n plus 1 into x raised to n plus 1 upon n plus 1 factorial is this n plus 1 into n factorial. Divide by an is this n factorial minus 1 raised to n into x raised to n. Right. So you can cancel out x raised to n, you can cancel out n factorial. So what is this? This is equal to limit n tends to infinity absolute value of x upon n plus 1, and this is equal to 0. This is equal to 0 and 0 is less than 1 always. So here the limit is independent from x. See, in these two examples what happened? The limit depends on x. The answer depends on x. In this example also, limit depends on x. Limit depends on x. Right. But here there is no x. That means you can choose any value of x. For any value of x, so if you look at the real line, then for any value of x, you can choose any value. For any value of x, r is always less than 1. That means for what does it mean? The interval of convergence is what? Whole real line minus infinity to infinity. And what is the radius? The radius is infinity. Radius of convergence is also infinity. Whether what is happening this side, r is equal to limit n tends to infinity absolute value of an plus 1 is this n plus 1 factorial is n plus 1 into n factorial x plus 2 raised to n plus 1 divide by n factorial into x plus 2 raised to n. Let us cancel out the quantities, n factorial cancel out. Right. So this is equal to limit n tends to infinity absolute value of n plus 1 into x plus 2. So this is equal to absolute value of x plus 2 into limit n tends to infinity n plus 1. Now what happened here? This is infinity. This goes to infinity only when x is not equal to minus 2. But when x is equal to minus 2, this quantity is 0. So this is equal to 0 if x is equal to minus 2. When x is not equal to minus 2, this goes to infinity. Goes to infinity means it is more than 1, and 0 means it is less than 1. So this is less than 1, r equal to 0 is less than 1, r equal to infinity is greater than 1. So this is the case when the series is convergent. This is the case when series is divergent. The series is divergent. That means the series is converges only for a single point, right? Therefore, the series summation n equal to 0 to infinity n factorial into x plus 2 raised to n converges only if x is equal to -2, and this is not the interval, this is a point, right? So the interval of convergence is only the single point -2, and the radius is 0, and the radius is 0 here. This is the end of these two examples. I hope the idea is clear for the radius of convergence and the interval of convergence.